Hey peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the Grade 11 2018 Physical Science paper, and these are a few of the multiple choice questions as part of question 1. Okay, so let's get right into it. Okay, so the first question says, two forces, F1 and F2, act on a point. If F1 and F2 act in the same direction, the maximum resultant has a magnitude of 13 newtons. If the forces F1 and F2 act in opposite directions, the magnitude of the minimum resultant is 3 newtons. The magnitude of the two forces in Newton is. Okay, so let's draw this little point here. And if we do the first case of F1 and F2 acting in the same direction, we know that this must equal 13 newtons. In the second case, if we draw them not equal to each other, so in the other direction, that must equal 3 newtons. Okay, so we know that whatever our answer is, the answer has to sum up to 13 newtons, as we can see here. Okay, but the trick is in the opposite direction. So whatever you are adding to the right, you have to minus from the left, or so on and so forth. So if you look at the answers, you might be tempted to put 3 and 10. But if you think about what that means, if we say that F2 is, let's say, 10, and F1 is 3, then the actual resultant there is 7 newtons. So it can't be that one. So what it actually is the next one that adds up to 13, which is 8 and 5. So that is A. Okay, number 2 says, a free-moving block slides down an inclined plane at a constant velocity. This means that, okay, it's either the frictional force acting on the block is 0, net force acting on the block is in the direction down the slope of the plane, the net force is acting on the block is 0, or the component of weight parallel to the plane is greater than the frictional force. Now, the problem with A, B, and D is that they all imply that there's some sort of resultant force. But we know that if it's traveling at a constant velocity, then we know that F resultant, or F net, is equal to 0. So that makes C the answer. Okay, going on to 3. It says a trolley is pushed down a horizontal surface with a force of 150 newtons at an angle of 45 degrees to the horizontal. The trolley experiences a constant frictional force of 60 newtons. The net force on the trolley can either cause the trolley to accelerate horizontally, it can be equal to the applied force, or is horizontally forward. And we've got to pick the answers to those. So if we think about this problem here, so will it cause the trolley to accelerate horizontally? Yes, absolutely. Because you can see that this 150 newtons has some sort of force in that direction and that direction. And if we work out what the horizontal component of the 150 is, we know that is 150 cos 45, which is equal to 106, around there. 106 newtons, which is greater than 60 newtons, which is the frictional force. So that means that there is some sort of resultant force that isn't equal to 0. So we know that it accelerates horizontally, so 1 is true. It's not equal to the applied force because you've got a frictional force acting to the left. So not only will you have this horizontal force in the right direction, going in the right, you'll also have this frictional force that opposes it. So it's not only equal to that. So 2 is wrong, this one here. And if the net force is horizontally forward. So yes, there is a net force horizontally forward, as we've explained here. So then the answer would be C, 1 and 3. Great. So let's go to the next set. Okay. It says a man in a lift is moving upwards at a constant speed. The weight of the man is W. According to the Newton's third law, the reaction force of the weight is the force of. Okay, so now we know that weight is the force that the earth exerts on everything else. So in this case, it's the force of the earth on the man. But they've asked for a reaction force to that. So the reaction force to the earth on the man would be the man on the earth. So I'm just going to write man on earth. And that is D. Okay. Moving on to 1.5, it says the optical density of a medium, and this is a definition question. So it either says will be high if the refraction of light is less, is a measure of the refracting power of the medium, is less when light bends towards the normal when entering the medium, or will be high if light moves faster through the medium. But it's a definition question, and we know the answer to that is a measure of the refracting power of the medium. The rest aren't relevant. Cool. Going on to 1.6, it says in which one of the graphs below will the gradient represent the refractive index of a material when light passes from the air through the material? Okay, and then we know that that answer is going to be D straight away. And that is because of the formula, this formula that I'm writing down here. So we know that these ends are constants. And so you can say that as this incident angle increases, this refractive angle, sorry, that's not 2, that's an R, will also increase. So that makes it a directly proportional straight line relationship. The reason it's not the angle, and it is just the sine term that increases and the sine term that increases. Otherwise, if it were just the angle, it would be increasing sinusoidally, in which case the straight line relationship wouldn't be valid. So it is this term that has to increase for this term to increase as well, which is why it is D. And we know obviously that the refractive angle is the independent variable, which is why it's on the X. Okay, great. Moving on to the next ones. Okay, so 1.7 says every point on a wavefront acts as a point source of spherical secondary waves that move forward at the same speed as the wave. This statement represents, and this is just a definition question, and we know that that is Huygens principle. Okay, then there's another electrostatics question there. So it says 3 charges of magnitudes plus 2q, and minus 2q are shown in the sketch. Which arrow correctly indicates the direction of the net force acting on the minus 2q charge? So when they say acting on the minus 2q charge, it means what is the minus 2q charge experiencing? So we know that there is a plus charge here and a plus charge here. So the minus 2 is going to be drawn to both of those. So if we draw just the minus 2q charge here, we know that it's going to be drawn towards the plus 2q charge horizontally and towards the plus 2q charge vertically. So that would mean its resultant goes something like this, which makes the answer A. Okay, moving on to 1.9. It says which one of the sketches below represents the correct magnetic field pattern around a straight current carrying conductor? Okay, and the reason I've put that little thumb there is because it's the right hand rule. So you point your thumb in whatever direction the current is flowing, and then the direction in which your fingers curl represents the magnetic field pattern. So that's how you know that the answer is B, because if you put your thumb going into the page, then the actual magnetic field is going to curl around in a clockwise direction. So that's B. Okay, and then the last one, 1.10, says which one of the graphs below correctly represents the relationship between potential difference and current in a non-ohmic resistor? Important that it says non-ohmic. So remember that Ohm's law says the following. It says voltage is equal to current times resistance, which means there's a straight line relationship between the current and the voltage. But that's only if the resistance is ohmic. So if it's non-ohmic, the voltage is still going to make the current increase if the voltage increases. So the one is still going to increase as the other increases, but it's not going to be a straight line relationship. which means that it's going to be C. Okay, so that's it for this question, but before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. You can also be sure to visit our website for more of these epic tutorial videos, and if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until the next time, stay epic.